Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now an oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane, as well as the vertical plane. And since this line happens to be inclined to both the reference planes, so neither of the front view or the top view they will be parallel to the XY reference line, and the projections of the oblique line onto horizontal plane as well as the vertical plane will reveal the apparent length of a line, and we will not be able to obtain the true length of a line onto the horizontal plane or the vertical plane. Now since the oblique line, it happens to be inclined to both HP and VP, it will be having both of horizontal trace as well as the vertical trace, and the traces they will be drawn through the projections A dash, B dash and AB. And we must remember this thing, that the traces they are never drawn through the true length projections of the line over there. Now let us read out the statement. The front view of a line AB, it happens to be 45 degree inclined to the horizontal plane. So we have got the angle alpha. So angle alpha, it is the angle of inclination of the apparent length of a line in elevation. So this is equal to 45 degree. And the front view of the line, it measures 50 millimeter long. So we have got the length of the front view, which is an apparent length, it is equal to 50 millimeter. And it will be marked as A dash B dash distance onto the front view projections over there. Now we have got the top view of the line, it is inclined at an angle of 50 degree to the vertical plane. So the inclination of the top view projections, that is AB, with respect to the vertical plane, so this angle we have marked as angle beta. So angle beta, it is equal to 50 degree. And we are also provided with the coordinates corresponding to the end A. So end A lies 10 millimeter above the horizontal plane and 15 millimeters in front of the vertical plane. So it means that this end A of the line AB, it happens to lie in quadrant number 1. Now with this information, we are required to draw the projections of the line, and we are required to determine the true length of a line, the inclinations of the true length with the horizontal plane as well as the vertical plane, that is the angle theta and angle phi need to be evaluated. And finally, we will be evaluating the traces of the line, that is horizontal trace and the vertical trace of the line we are going to find out. So let us start with the projections of the oblique line. So here we have got the XY reference line. So we know that the end A of the line, it happens to lie 10 millimeter above the horizontal plane and 15 millimeter in front of the vertical plane. So this distance of 10 millimeter we have to draw above the XY reference line, and this distance of 15 millimeter in front of the vertical plane, so this will be drawn below the XY reference line. So this distance, this happens to be 10 millimeter, and this is the distance which is equal to distance in front of the vertical plane. So this will be equal to 15 millimeter. So we have been able to obtain the coordinates corresponding to the A dash point as well as A point, right? So this is the projection of the end A in the front view, and this is the projection of the end A in the top view. So end A corresponding to the line AB has been located onto the, now we are given that the front view of this line AB, it measures 50 millimeter in the front view. So we know that this A dash B dash distance, this happens to be 50 millimeter, and the angle of inclination of this apparent length in elevation, this happens to be 45 degree with respect to the horizontal plane. So now we are going to draw this angle alpha over here. So angle alpha, it is equal to 45 degree. Now I can draw this particular apparent length projection of the line in the front view, that is A dash B dash, it is equal to 50 millimeter. So this is the front view of the line in elevation. So once I draw this front view distance over here, now a horizontal projector line corresponding to the locus for the point B dash will be drawn over here. Now once I have obtained the location of this point B dash in the front view, so one thing I know that point B, which is the projection corresponding to the end B of this line in the top view, this will be obtained in the vertical direction from this particular point B dash over here. Why? Because B dash and B point, they will be lying on a vertical projector line corresponding to this XY reference line over here. Now, having drawn this particular projector line onto which my point B will be lying, now I have got another information available with me. That is the orientation or the inclination of the top view projection AB with respect to the vertical plane. It happens to be angle beta is equal to 50 degree over here. Now with this orientation over here, so I have already located the point A in the top view. Now from point A, I will be drawing this angle of beta is equal to 50 degree. So once I mark this angle of beta is equal to 50 degree over here, now I can draw a projection line which will be my projection line AB. So I have to extend it till it meets this vertical projector which is emerging from the point B dash from the elevation view, because we know that B dash and point B, they will be lying on the same locus of the vertical projection line over here, which will be perpendicular to the XY reference line over here. So this way I know this orientation of the plan projection line, which is at an angle of 50 degree with respect to the vertical plane. I know this orientation as well. So wherever these two projection lines they are going to meet, I will be obtaining the top view projection of the line AB in the horizontal plane, right? So front view projections of the line they have been obtained, the top view projections of the line they have been obtained. Now I need to evaluate the true length of the line in the front view and true length of the line projection I need to evaluate in the top view projections over here. So in order to draw the true length of a line in the top view, I know that whenever my projection line corresponding to the apparent length in the front view, it happens to be parallel to the horizontal plane. So on the horizontal plane, I will be able to obtain the true length of a line over there, and I will also be able to evaluate angle phi, which is the angle of inclination of the true length of a line with respect to the vertical plane over here. Now I will be using the method of rotation of line to evaluate the true length of a line in the plan. So what I am going to do, I have got this apparent length projection corresponding to the line AB. So this happens to be A dash B dash. Now this will be my compass point, this will be my pencil point. So I'll open compass equal to the distance A dash B dash. So I have to draw an arc through point B dash till I reach the locus line of the point A dash over here, so that the projection line A dash B dash, it becomes parallel to the horizontal plane. Now I have rotated this edge over here, A dash B dash, so that this edge or the projection in front view, it becomes parallel to the horizontal plane. So the new point which is obtained over here, this will be called B1 dash, and the direction of the rotation has also been marked over here. That is, I have started from B dash and I am going to move on to get to the point B1 dash over here. So having obtained this point B1 dash, now I have got the length of the front view which is parallel to the horizontal plane. Now from this point B1 dash, I will be dropping a perpendicular projection up to the point B of the plan over here. So this is the locus line corresponding to the point B, and we know that the point B and B1 over here, they will be lying on the same horizontal locus line. Now through this point B1 dash, I am going to drop a perpendicular projector onto the locus line of the point B, which is the second point of the line AB, which is appearing to us in the top view projections over here. And once again, the arrow of this movement we have marked over here, that is, I am moving from this point to this point. So if this point name was B1 dash, so the point which I am going to obtain over here in the top view or in the plan projection, this will be B1. So B1 dash and B1 points, they will also be lying in the same vertical line projection over here, right? So having obtained this point B1, I have been able to obtain the true length of a line. So this color I have changed corresponding to the true length. So the apparent length we had marked with black color. Now the true length we are going to mark with blue color, just to distinguish between apparent length projections and the true length projections over here. So this is the true length of a line AB1. So this happens to be the true length of a line, and once we have obtained the true length of a line, I can obtain the angle of inclination of this true length with respect to the vertical plane over here. And the name of this angle is angle phi. So we can check out over here, true length of the line, it is having larger distance, it is bigger than the apparent length of a line, whereas vice versa will be true for the angles of inclination. That is, apparent angle of inclination beta, this will be greater than the true angle of inclination of the true length with respect to the vertical plane. So apparent angle beta, it is greater than the true angle, whereas the true length, it is greater than the apparent length of a line. Now I need to obtain the true length of a line in the front view. So in order to obtain true length of a line in the front view, I know that whenever my apparent length projection AB, it will happen to be parallel to the vertical plane, then onto the vertical plane I will be able to obtain the true length of a line in the front view, right? So on the vertical plane in the front view, I will be able to obtain the true length of a line. So now what I am going to do, I have got my AB projection, which is the projection of the line in the top view. So this happens to be inclined to the vertical plane. So this will be my compass point, this will be my pencil point, again using the principles of the rotation of the line. So this line, that is this projection line AB, I am going to rotate so as to make this particular line, so as to make this particular projection line parallel to the vertical plane. So please check, this is my needle point of the compass. I open the compass this much with A as center. I will be rotating this line till I am able to obtain this line AB2 parallel to the vertical plane. The moment I obtain this line AB2, this is my apparent length projection line over here in the top view. So once my apparent length projection in the top view, it happens to be parallel to vertical plane, now I will be dropping a perpendicular through this point, through the point B2, and once again the arrow of movement of this line I have indicated over here, and I'll keep on moving this projection forward till I reach the horizontal locus line corresponding to the point B dash over here. And once this vertical projector, it intersects with this horizontal locus line, I am going to obtain the elevation true length second point B2 dash, because here I have got the point B2 over here. So this point was B2. So on the upper side of this vertical projector, I am going to obtain the point B2 dash. So this is the second point of the true length as it appears to me in the front view. Now again, using a blue color dark line, I am going to join A dash with B2 dash over here. So the moment I obtain this blue line A dash B2 dash, so this gives me the true length measurement in the front view. Now I need to check whether this A dash B2 dash, it is equal to AB1, because you cannot have an oblique line having two true lengths. So this true length, that is A dash, B2 dash must be equal to AB1. So if you are able to obtain both of these two lengths equal, it means that whatever rotation we have made, whatever iterations we have carried out, so they have been carried out perfectly over there. Now, having obtained this true length, now I can evaluate the angle of inclination of this true length A dash B2 dash with respect to the horizontal plane, and this angle we can mark. So once again, true length in elevation will be bigger than apparent length in elevation. Apparent angle of inclination alpha will be greater than true angle of inclination theta over here. So this way, apparent angles, they are greater than the true angles. True length will be greater than the apparent length over there. Now, having obtained these projections and the angles of inclinations, now next we are going to evaluate the traces of the line. And as we have discussed, traces of the lines, they will be obtained by extending the apparent length projections in the front view and the apparent length projections in the top view. That is, they will be obtained through these black lines A dash, B dash and AB. So first of all, we need to evaluate whether these projection lines A dash, B dash and AB, whether they are intersecting with the XY reference line themselves or not. So both of them, A dash, B dash and AB, they are not intersecting with the XY reference line. So we need to extend these lines over here. So let me extend this line A dash, B dash. So once I extend this, wherever this extended line intersects with the XY reference line, I obtain the point H dash over here. Similarly, now I need to extend this projection line AB. Now I work out that this particular projection line AB, it is going to intersect with the XY reference line at this particular point. So name of this point will be point V over here. Now from H dash and from V, I will be drawing perpendicular projections so that these projections, they will be meeting the projection line which is coming from the other end. So from H dash, once I draw a vertical perpendicular, I need to extend it up to the point where this vertical projector, it will be meeting the plan projection line which has been extended over here. So it will be meeting this extension line AB at the point H over here. Similarly, this plan projection line AB, it was meeting the XY reference line at the point V. So from the point V, I will be drawing a vertical projector and extend it up to the point where it will be meeting the extended line A dash, B dash. So A dash, B dash has been extended over here. So wherever this vertical projector, it is going to meet the elevation projection line which is extended at the point V dash over here. So this distance will give me the vertical trace of the line. This measurement of the distance H dash H, it will be giving me the horizontal trace of the line. So I need to measure the distances H dash H to evaluate horizontal trace. I need to measure the distance V and V dash in order to evaluate the vertical trace of the line. So this is the discussion regarding the evaluation of the projections of the oblique line, evaluation of the true lengths and the inclinations of the line with respect to HP and VP, and finally we have evaluated the procedure to evaluate the horizontal trace as well as the vertical trace of an oblique line. So I hope that through this discussion you would have understood about the mechanism to evaluate the projections of the line, true length of a line, working out the inclinations of the line with the reference planes HP and VP, and finally we have evaluated the traces of the line. So we'll be continuing with further discussion regarding few more illustrations regarding the projections of the oblique lines in the coming lectures. So this is all for today. Thank you very much.